Well, after all that, let's go ahead and do an example. And this is 6-3 example 1. And they say, well, let's calculate the length of that curve. And of course, that's a circle. So what we're going to actually calculate is what is the circumference of a circle of known radius r. Well, to start with, we need a parametric representation, and we know that x in this case is going to be equal to r cosine of t, and y is equal to r sine of t. But think about this. What values must t be taking? If we look at this, we realize that t is going to start at, so t0, I guess, is equal to 0, and t final is equal to 2 pi. Therefore, we go one cycle around. Otherwise, if we put something else, we'd find the length of, I guess, multiple trips around the curve. Okay, anyway, we've got our times, we've got our functions. So what we're going to need to do to use our definition is we're going to have to integrate from 0 to 2 pi, and it's going to be the square root of f prime x quantity squared plus g prime x quantity squared. Actually, let's put t's in here, right? dt. Something like that. And now we need to figure out what our derivatives are here. So the derivative of r cosine t is equal to minus r sine t. Derivative of this is equal to r cosine t. So now we can plug those in and we get square root of r, minus r sine t quantity squared plus r cosine of t quantity squared dt, integrated over 0 to 2 pi. Okay, so now we've plugged in our values, and we can go ahead and integrate. Now, before you jump in and start trying to integrate this, we might do a little bit of algebra and realize that we can reorganize this into being r squared times sine t squared plus cosine squared of t. And wait a second, there's a math identity, trig identity. This is just equal to 1. So this kind of daunting integral simply becomes 0 to 2 pi of r squared dt. And if we take the integral of this, scroll down here, and take, well, no, wait a minute, that doesn't look quite right. Oh, we forgot a square root sign. Yeah. Okay, good. Oh, we can simplify this even more. Great. 0 to 2 pi of r dt. And r, remember, is a constant. Our variable is t, so what we're looking at when we integrate this is we just get rt evaluated from 0 to 2 pi. And this is equal to 0 plugs in 2 pi, we get 2 pi r. Okay? And indeed, that is the equation for the circumference of a circle. So I guess it worked.